on page 303, they give you a little breakdown of placing the triangles. It's basically the same steps. I'd like thinking about it first with numbers before I do it myself. So um, they kind of give a generic step by step here. It might be useful for you. It's on page 303. But let's go to example 2. We're going to identify missing coordinates. Now, for example 2, we're going to identify missing coordinates. And if you take a look here, we've got 3 coordinates, x, y, and z. And I know some of the things about them. Like I know the x coordinate for a or for z is a, but I don't know what the y coordinate is yet. For y, I don't know what either of the coordinates are, and for x, I don't know what either of the coordinates are either. One thing to always start with are any of the points on the origin. And I see that point x is actually relating to the origin there, and I always know what the origin is. It's 0, 0. So now I've got coordinate x all filled out. Now for z, I notice it's on an axis. So that's the next thing I want to look for. Are any of the points on an axis? Because if they're on an axis, that means one of the coordinates is 0. And here for z, since it's on the x-axis, I know the y-coordinate I should write these in red here so you can see what I'm filling out. 0, 0. Since z is on the x-axis, I know the y-coordinate is 0 as well. Now, y is the tough one here. Now, I know this is an isosceles triangle, and my bet is that those two sides are the congruent sides, right? So, does it matter how tall it is? Like, could it be super, super tall or could it be super short? Yeah, it could be any height there. So since it can be any height, I just need some other number to be my y coordinate. So I'm just going to call it b. It doesn't matter what it is. It could be 2, it could be 37. It could be anything, right? But when I take a look at that x coordinate, there's something happening there. Like I already know from the origin, I'll highlight it in bright green here. From the origin over that to that point z, that's a units long. And if this is isosceles, that means that that vertex angle is halfway in between, right? So from here to here is half of a. From that point down over is also half of a. And that gives me a clue to what the x-coordinate has to be. It has to be 1/2 of a. And now I've got all my coordinates. So it's all about figuring out if they give you some sort of relationship that already exists, like we know that the base is a units long. Think about the type of triangle or object you're working with and trying to figure out, do you know anything about how it's split apart? Is it cut in half? Is it supposed to be twice the length? Is it going to be on one of the axes? Do I already know one of the coordinates that way? You're just trying to think through all the different parts there.